So in this video, I'm going to talk about graphing the residuals. And we go back to our original line. We have Asians, and this is years before and after myopia onset and refractive error. I already mentioned we're violating a few assumptions because the assumption is that the relation is linear, which clearly it's not here. There's another thing that there's this concept of called falling off the cliff. So with respect to myopia. So the year that you have onset, there's a bigger jump in the change. If we look down through here, you can see there's kind of this is 0 and -1. There's kind of a bigger jump in this line. And here we go, and so forth. So we're going to see if we can see that in the residuals. So we had saved the t-standardized, the studentized residuals, the t-test, based on the t-test. And let's graph those. Let's do our legacy. And we could do a scatter dot plot. In fact, let's do that first. So we look at years before and after myopia. We're going to come down to our studentized residuals. And we're going to plot them out. And here is that 0, 1, and so this is our residual. If we bring in a vertical line and set it to be at 0, residuals should fall equally on both sides of the 0 of the 0, because the mean of the residuals is 0. And so we should see equal variability on both sides of that. So you can see there's a kind of almost a straight line up there, and then there's kind of a flat line there in terms of our residuals. So there is more variability to be accounted for outside a linear model. But notice this big gap right here. It just really looks different. And that's 1 year before to 0. You can go in and click on this, go to scale, and change that to a 1. That gives us our single years. And if we come to our vertical line, make that go at 0, you can kind of see right there how that's different. Similar pattern with African Americans, similar pattern with Hispanics. That's Caucasian, excuse me. Similar pattern with Hispanics, African American. So let's go in and do a box plot. Same thing. It looks about the same. Actually, in this case, almost the break isn't as obvious in the Asians, although it's still there. You can see a nice break in the African Americans, a little bit of a break in Hispanics, break in, not really much of a break in the Caucasians. So a lot of outliers on this guy. We should probably trim our data and try again. Anyway, that's how you graph residuals. And you should always look at your residuals after you've run the study. Remember, the residuals over here reflect standardized scores. It's like z-scores. And we come up here to our Asians, double click, and click over here, double click, go to scale, major increment, we want to be 1 to change from 0, 2, 4 to 0, 1, 2, 3, 4. So you can see it a little bit better. We can add our vertical line in at 0 and our horizontal line at 0. So that makes it a little bit more obvious. So this is 2 standard deviations out. These are 3. You got some points that are pretty far out. That's where those outline residuals were shown on our printout before. Diagnostics, these guys. It's not those guys. Case-wise, these different case numbers, those are the ones that are falling below 3 standardized residuals. And that's how you plot residuals. You should always do it. See if your model has additional variance that can be accounted for outside a linear model.